Hello everyone, welcome back to the channel. Today we are doing exercise 7.3, question 8 to 14. Question 1 to 7 are in the previous video and the link is in the description below. For now, grab your books and pen for question 8. So the question here is 1 minus cos x upon 1 plus cos x. We will have to apply the formula which is tan square x by 2. In this exercise, which is entirely based on trigonometric functions, you should be very much clear with the formulas. So if you know the formulas, it will become easier. So put these formulas down separately and refer to them as many times as possible. Okay, so now what's the formula for this? Tan square x by 2. Now we know tan square is one function which cannot be integrated directly. In the previous video we saw that which functions can be integrated directly. One is sec square theta, which is tan theta. Another is cosec square theta, where we directly have the formula as minus cot theta. For all the other functions, square functions of the trigonometric functions, we need to apply some or the other formula first and then we need to go to the integration. These are the different formulas. No? This too can be integrated directly. Over here tan square theta, we will first have to apply the identity which we learned in class 10, that is sec square theta minus 1, and then you can integrate it. Same for cot square theta, cosec square theta minus 1. For cos square theta and sin square theta, this we have studied in class 11, that cos square theta is 1 plus cos 2 theta by 2 and sin square is 1 minus cos 2 theta by 2. So apply this different formulas first and then you can integrate it. So in this case, that is tan square x by 2, we will have to apply this identity. It becomes sec square x by 2 minus 1 dx. So integration of sec square is tan, so it will become tan x by 2. But as we see, this is x by 2 and this is x, so we'll have to differentiate x by 2 in the denominator. Integration of 1 is x and c, integration constant. So derivative of x by 2 is half in the denominator, so it becomes 2 tan x by 2 minus x plus c. That's the integration of this function. There are two ways of doing this question. One is you rationalize the denominator 1 minus cos x and 1 minus cos x in the denominator. So this becomes cos x minus cos square x and denominator is 1 minus cos square x. Now the formula for 1 minus cos square x is sin square x. So we will write here sin square x. Separate this cos x upon sin square x and cos square x upon sin square x. So this becomes cos upon sin, which is cot x, another sin x which is left in the denominator, so it will become cosec x, and this is cot square x, but cot square x cannot be integrated directly, so we'll write this formula cosec square x minus 1 dx. Now integrate this. Integration of cot into cosec is minus cosec x. Cosec square x is minus cot x, so minus minus plus, and this also plus x. So that's your answer. This is one way of doing. Another way of solving the same question is we can apply the formula of cos x, that is cos square x by 2 minus sin square x by 2, and 1 plus cos x is 2 cos square x by 2. So when we split this up, write this separately, it is going to become integration half minus sin upon cos is tan square because it is sine square upon cos square. Now integrate this. This is half into integration dx, half into integration of, we'll write dx here, half into integration of tan square, which again cannot be integrated directly. So let's write sec square x by 2 minus 1. So this is half into x, sec square is tan x by 2. Once again, it is not x and here the variable is x. So differentiate x by 2 in the denominator, minus minus will become plus, integration of dx is x. So we have half x plus half x, that is x. This half will get cancelled. So now this answer looks different from what we got in the previous method, okay. But when you simplify that, when you convert that x to x by 2 or convert this to x, it will come out to be the same. Let's see. It's not a must to be done in the exam. Your answer is correct. Both the answers are right, okay. So if I want to convert this to like the previous one, we'll multiply and divide with 2 sine. So 2 sine square x by 2 is 1 minus cos x and denominator is sine x. So now you see it got converted to x. Now if I separate this out, 1 upon sine x is cosec x and minus minus will become plus, cos upon sine is cot x, and that's the answer like the previous one. So both the answers are correct. This is also correct and this is also right, okay. So you can do either one in the exam. You need not convert it like this. I am just showing you to see that both are the same answers, only it needs to be converted in the other form, okay. So you can do either of the method. If you are very well with the formulas, you can use this and do, otherwise you can rationalize, like 1 plus cos x is there, you multiply and divide with 1 minus cos x. So the square or the fourth power or the sixth power of this trigonometric functions cannot be integrated directly. So first thing we'll do is write this as sine square x square. Since we know the formula of sine square x, which is 1 minus cos 2x by 2. Keep on simplifying this unless the powers are solved, okay. So this is square of 2, 4 and whole square, 1 minus 2 cos 2x and this is cos square 2x. But still you have cos square, okay. So write the formula for that also. What is cos square theta? 1 cos square theta is 1 plus cos 2 theta upon 2. So now since we have 2x here, it's going to become 4x. So we have 1 plus cos 4x upon 2. Now let's take LCM. So we'll have 2 here, 4. On further simplification, it becomes 1 upon 8 integration 2 plus 1 3, and now the only thing left is to integrate this function. So it's like more of simplification and the integration is quite easy. What is integration of cos? Okay, we'll start with 3. Integration of 3 dx is 3x. Integration of cos 2x, 4 as it is. Cos 2x is sin 2x, and again because this is not x, differentiate it in the denominator, and cos 4x is sin 4x upon 4, same thing, because it is not x, differentiate 4x in denominator and the integration constant. Okay, then you can multiply that 1 by 8 and simplify. So that's your final answer. So this is a similar question. First thing we'll do is write this as cos square square and write the formula of cos square theta. So that becomes 1 plus cos, double the angle, and yes, of course, whole square is there, right? Because cos square theta is 1 plus cos 2 theta by 2. So whatever angle here, it will become double. 2x will become 4x. Again, square of this, whole square, a square plus 2ab plus b square. Further, we will have to simplify. We still have cos square 4x, okay. So this is 1 plus 2 cos 4x, cos square 4x formula, 1 plus cos double the angle, once again the same formula. And now simplify and integrate. So once again, when you take 2 as the LCM, it's going to be 8 over here. This is 2 and 1, 3 plus 4 cos 4x plus cos 8x. I have taken LCM and added this 2 and this 1. Okay, so integration of 3 is 3x. 4 cos 4x is 4, cos integration is sine, and 4x because it is 4x and this is x, once again derivative in the denominator, sine 8x and 8. I hope that's clear. Why do we have 8? Because it is 8x and this is x. So we differentiate 8x in the denominator. For integration, this is only possible whenever we have a linear change in the place of this x. That means in place of x you may have 2x, you may have x plus 2, you may have x by 2, like that. Then only you differentiate in the denominator, otherwise we will have to go with substitution method. Okay, this is also actually substitution, but it comes out directly by differentiating in the denominator, so that's fine. Now because we have sine square x and we have 1 plus cos x in denominator, it's better that we write 1 minus cos square x. Whenever we are solving any integration questions, we would prefer that all the angles are the same. So you could also have substituted 1 minus cos 2x by 2 for sine square x. No, that's the other formula. But we don't do that, because then the angle here, like suppose if I write 1 minus cos 2x upon 2, then the angle in the numerator will be cos 2x and in denominator it will be x, which will turn out to be difficult to solve. So we'll not do that. It's not that it's not possible, but it will become a bit lengthier. So which one is easier? Writing sine square x as 1 minus cos square x, and when we write that, we can apply a square minus b square formula. So this becomes 1 plus cos x, which gets cancelled. Okay, and now simple integration, integration of 1 x, integration of cos x sin x, that's it. This is an easy question, but this is one question where students make mistake. Let's see where the error may occur. So the first thing is, because the angle is different, we need to convert it to the same angle to make it easier. So what's the formula of cos 2x? It is 2 cos square x minus 1. What is the formula of cos 2 alpha? 2 cos square alpha minus 1. So for cos 2x, you need to think which formula to apply depending on what else is there in the question. Like in this question only cos is there, so we will not apply cos square x minus sin square x or 1 minus 2 sin square x. We will apply the formula of cos 2 theta in terms of cos. Okay. So now this is 2 cos square x minus 1 minus 2 cos square alpha, and this will become minus minus plus, cancel. As we see, 2 is common in the numerator, so let's put it outside the integration sign, and the rest is a square minus b square, a minus b, a plus b. So cos x minus cos alpha will get cancelled. Now it is integration of cos x plus cos alpha. Now as we see, the variable is x, right? So integration of cos x is sin x, but integration of cos alpha, which is constant, will be as it is, and then nothing is there, so integration dx, which is x. This is one place where students make mistake. Instead of writing cos alpha into x, you may tend to write sin alpha. But remember that cos alpha is constant, our variable is x. So it's something like, say, half is the value, maybe. So half dx, what it will be the integration? Half will go outside the integration and 1 dx, similar to that. Okay, so cos alpha, or if you write all the steps, it becomes like this: 2 integration cos x dx plus 2 cos alpha integration 1 dx, and that's why you have this. Okay, so make sure that you don't make any mistake over here. So now once again we have 2x here and x in the numerator. Converting to x is easier, we'll convert this. So if you know one concept, that is that preferably all the angles should be same in the integration, it becomes so easier, so many questions can be done. Okay, so let's convert this sine to x to x angles. So that is 2 sin x into cos x. Now simply writing 2 sin x into cos x with plus 1 is not going to help us. So we'll write this as cos square x plus sin square x. In place of 1, we are writing cos square x plus sin square x. What's the benefit of this? Yes, so in the next step we have it as cos x plus sin x the whole square. Right? It is cos square x plus sin square x plus 2 sin x cos x. A square plus b square plus 2ab. So instead of this, we can write cos x plus sin x whole square. And now I think it's quite clear, because if you take this as t, the rest is going to become dt. So let's substitute. Let cos x plus sin x be t. So what's the derivative of this? Cos x derivative is minus sin x. Derivative of sin x is cos x. Dx equal to dt. That's the numerator, cos x minus sin x. So numerator became dt, denominator is t, and this is 2 square, so t square. So this is to be integrated like t raised to minus 2 dt, which is t raised to minus 1 upon minus 1. Which formula? X raised to n. X raised to n plus 1 upon n plus 1. This is the formula which we have applied here. So on further simplification, it becomes minus 1 by t. Okay, this minus sign here, t in the denominator, put back the value of t, cos x plus sin x. So the answer is minus 1 upon cos x plus sin x, and of course the integration constant plus c. Okay. So that's how you can do this kind of question. Whenever you have different angles, see that you convert it to the same and then try to simplify. I'll be putting up the formulas related to this exercise on my Instagram page, so you can download it from there. See you in the next video.